Hello again, everyone. It's Dave Giles here with the fourth lesson of Unit 2 for Cambridge International Physics. This lesson is on thermal expansion. So today I want to describe the thermal expansion in solids, liquids, and gases. As well as that, we'll be looking at some applications as well of thermal expansion. So in the classroom, what you'd normally do if you talk about thermal expansion is do a little practical to start things off. And it's with this little set of equipment here, which is basically a hoop and a ball. You start off by passing the ball through the hoop, and it passes through fairly easily. You then heat up the ball in a Bunsen burner. Usually takes a few minutes. You then try and pass the ball through the hoop again, and you find that the ball will not actually pass through the hoop now. And the reason for that is that the ball has expanded due to the heat. So we're going to look at, first of all, why it expands. So many substances expand when heated. When heated, the particles, atoms or molecules in the substance vibrate more, which means they need more space. So the substance expands. So you see that it is cold. After heat is added, the substance itself expands. Now, you've got to be very careful here with your wording. Don't say that the particles expand or the atoms expand. That isn't true. What happens is the space between the particles expands instead, not the actual particles. So questions on heating solids, very quick ones. The particles have increased in size following thermal expansion. Just talked about that a second ago, and the answer is no. The particles don't increase in size, it's the space between them. True or false, the particles are now able to move about and change position when heating a solid. I will add to this question. The answer is false, because that only happens in liquids and gases. And the particles now have more kinetic energy. True or false? They do now have more kinetic energy, so that is true. So here's some train tracks. Would you be happy in a train traveling along these? And the answer is probably going to be a no to that. So what's happened to the train tracks? Well, the metal that makes up the train tracks has expanded and the tracks have buckled or kinked. So that's obviously not a good thing. So we're going to look at ways to prevent that from happening. So one way to do it is to leave an expansion gap. So this here is a bridge. I'm assuming it's going to be in a hot country. And you can see there's a big gap in the middle of the bridge, which may think looks like it's just not finished, but that is how it's meant to look. And that is deliberately designed so that if during the day the bridge gets hot and expands, instead of buckling it or basically crushing itself, it has room to expand without damaging the bridge. So these expansion gaps can be seen on other bridges. Over the course of the day, the bridge will expand and the expansion gap will close. As the bridge cools down at night, the expansion gaps will open up. So this road is buckled. What's happening if you look at my pic monitor there, if you think of two things expanding and they're trying to push past each other, eventually one will end up sliding under or one will slide over. So the one on the bottom will slide under, the other one will slide up, causing this buckling here because it's got nowhere to expand. So again, that's why we have the expansion gaps. So back to the railway from earlier. What's the solution to this problem? Well, same as the bridge. It's leave an expansion gap. So little gaps every certain distance along the train track, so that if it gets hot on a hot day or through the wheels, heating up the tracks, there's got room for it to expand without kinking like it has here. So one place you'll see this, or one application rather, is a bimetallic strip. Again, this is a practical you would normally do in class where you have a bimetallic strip, which is a piece of metal, or sorry, a strip of metal made from two different metals. Before heating it straight, and then when you heat it, it bends one direction or the other. So if we actually have a look at the big picture here on the right, you can see the top metal and the bottom metal are different material or different kinds of metal. And what happens is the one that expands the most, so in this case, it'll be the top one will expand more than the bottom. So it expands and pushes the one that expands less down or away. So the thermal expansion, or sorry, the bending, sorry, is always going to be in the direction of the metal which bends the least with a bimetallic strip. So you might be thinking to yourself, you know, where could this actually be used, a bimetallic strip? So here is an example. So you've got a heating element here, and it's heating up, say, a room. When the room reaches a certain temperature, you don't want it to keep heating forever and ever, otherwise it'll get extremely hot in there. So this is a device designed to switch the heater off once the room has reached a certain temperature, and it is a bimetallic strip. So you can see here it's made of two metals, invar and brass, and you can see brass expands most when heated, roughly 20 times more than invar. So this here is a circuit with it in, and here's a little description of what's going on. I want you just to think about what the answers are for the filling in the blanks. Give you a few seconds. Okay, so the answers to this are, when the temperature is low, the bimetallic strip straightens and the circuit is completed. The heater switches on and the room begins to warm up. When the temperature is high, the bimetallic strip bends as the two different metals expand by different amounts. The bending of the strip breaks the circuit. Current can no longer flow to the heater and the heater switches off. As a result, the room cools down again. So that is thermal expansion in solids. So a very quick look at liquids and gases. So the most common example of a thermal expansion in liquids you will see is a thermometer. So a thermometer is basically a tiny, tiny tube filled with a liquid. The liquid particle, when heated or when the temperature rises, the liquid particles gain kinetic energy and potential energy. By making the tube very narrow, a small increase in temperature will lead to a small increase in volume that leads to a large movement of the tube, where you can measure, say, a 0.1 or 0.2 degrees Celsius change with the thermometer. Also look at thermal expansion in a gas. So you can see here, we've actually got water. Now, the water's the thing, it's heated directly, but that heats up the inside of this flask. So the particles gain energy, they expand, they go into the balloon, and they cause the balloon to blow up. So now we're going to look at which of the solid three states matter, solid, liquid, and gases, expands the most. Well, the one that expands the least due to thermal expansion is a solid, because it's got the least space between the particles and they've got the strongest attractive force. Then in the middle, you've got liquids. They've got small space between the particles and moderate attractive force. Hence, they experience moderate amount of thermal expansion. And the one that expands the most due to thermal expansion are gases, because they've got the most space between the particles and the weakest attractive forces. So some very quick questions to start with. A bimetallic strip. Aluminium expands more than steel. Which way will these bimetallic strip bend when exposed to heat? To the left or to the right? Well, it always bends in the direction of the metal which has the least amount of expansion. So it's going to bend towards the steel. So it's going to bend right. The rest are true or false. When a material expands, its particles increase in size. Is that true or false? Again, the question I've already gave you, but it's just really worth hammering that point home. The answer is false. And finally, true or false, when material is heated, its particles gain kinetic and potential energy. That is true. The rest are now past paper 2 Cambridge International Examination questions. So an axle is too large to fit into the hole in a wheel that is made of the same metal. How can the axle be made to fit into the hole? Do you cool the axle? Do you cool the wheel alone? Do you cool the axle and the wheel? Or do you heat both the axle and the wheel? So if we start from the bottom, if I heat both the axle and the wheel, well, the gap in the wheel might get bigger, but this will also expand, so it'll become wider, so that won't make a difference because they both became wider. Similarly, if I cool them both, they'll both become smaller, so that's not going to work. If I cool the wheel alone, that'll decrease the size of the gap, which will actually make it harder to fit inside. So the answer is A, cool the axle alone. That'll make this become smaller, compress, so it can fit inside the hole. So the answer is A. Question 2. Which line in the table shows the relative expansion of the three states of matter from the most to the least? Well, the one that expands the most is gas. The one that expands the least is solid. So if liquid's been in the middle, so the answer is C. Question 3. The diagram shows a bridge on a cold day. The bridge is being built with a small gap at one end. On a warmer day, the bridge changes size and the gap changes size. What happens to the size of the bridge and what happens to the size of the gap? Okay, so the bridge is going to expand. So the bridge is going to, it's either going to be A or B. What will that do to the gap? Well, it'll make the gap smaller if that expands. So the answer is therefore B. Bigger bridge, smaller gap. Question 4. So this is an application of thermal expansion here. The diagram shows a design for an alarm. The mercury pellet moves and completes the circuit. Why does this happen? So the gas, if it's going to move, it's going to have to move towards this here so the mercury will complete the circuit. So the gas is going to have to expand. And that'll happen once the temperature rises. So the answer is D. And then question 5. We have a bimetallic strip with brass and iron. When the strip is heated, the brass expands more than the iron. Which shape will the strip become? Well, which one expands more? The brass expands more. So it's going to bend towards the iron, and it's only going to bend once. So the answer is B. So that's it for the multiple choice questions. I've now got some full past paper exam questions from paper 4. I'll let you pause it, then I'll put the answers on the screen. Yeah, there's the answers to question 1. Question 2, and question 3. Okay, that's the end of today's lesson. The next lesson is going to be on using the Kelvin scale. It's going to be a short lesson. So thank you very much, everyone. I'll leave a link to the next lesson in the comments below. Thank you very much, and goodbye.